evening. My name is Emil Lezak. I am representing IZNAB. This is SME from Warsaw, Poland. And I have the pleasure to present the workshop titled Transforming Construction Waste into Energy Efficient Solution. The workshop organized by two European projects, INOWI and Wool to Loop. Projects have received the funding from Horizon 2020. There is the list of the speakers. The first presentation will be given by Sergio Tamburini from CNR ICMATE, presenting the INOWI project. The second one by Mrs. Beatrice Fraga from Technalia about INOWI as well. The third one by Mrs. Rajeshi Ramaswamy from Oulu University, presenting Wool to Loop project. And the fourth one, the last one, by Mrs. Wilma Dukman from ZAC, presenting the INOWI and Wool to Loop project. So now I would like to give the floor for Sergio Tamburini. Thank you.
Okay, good morning to everybody. I'm Sergio Tamburini from CNR ICMATE Italy, and I talk about the INOWI project, innovative prefabricated components including different waste construction materials, reducing building energy and minimizing environmental impact. The INOWI project is an Horizon 2020 4-year project of research and innovation funded by the European Community and started in October 2016. The context in which this project was born are the 2.3 billion tons of waste produced in 2016 in the 28 countries of European Community, 1/3 of which are construction and demolition waste. The goal of this project is the use of this construction and demolition waste to produce innovative prefabricated panels to reduce the energy consumption of buildings. The project must develop products from technology readiness level 4 to 6. The consortium of this project is made up 10 partners from 6 European countries. Some of these partners are small industries, the most, and other are research bodies or national certification bodies. The main objective of the project are, first of all, the recovery and disassembling of selection and construction waste to produce high-quality raw materials. Then, to produce innovative and efficient construction products, produce then innovative and cost-efficient prefabricated panels, demonstrate real energy saving in different European climatic scenarios, and then transfer all this work into guidelines, training material, and dissemination. The structure of the project is quite linear. At first phase, there is definition, the selection of the waste that can be used. The second is the realization, then scale up of products identified. Third phase, the demonstration of effectiveness of products in real and virtual case studies. Fourth, evaluation of the economic and social processes of the product. And the fifth phase is the dissemination results of result, exploitation, and marketing introduction, marketing of the products. We have therefore introduced two important innovation in this project: treat the CDV to yield suitable raw materials first, and then use a new environmental friendly binders such as geopolymers. Talking about the first part of the project relate to the demolition waste. Everything starts with a selective demolition of building, a reasoned demolition in which all different materials of a building are divided, cement, mortar, brick, glass, wood, and all various metals. Then there is the reduction in the size of this waste through a process that the partner responsible of this activity has led to an extremely reduced final fraction of about 0.2 millimeters. The production plan has been so modified by adding an appropriate mills and sieves to produce a material that can no longer be defined as waste, but as a secondary raw material. We said we use geopolymers, but what are geopolymers? They are inorganic materials produced artificially in a process in which aluminum silicate are activated with alkali silicate solution. The name geopolymer means that they mimic natural compounds and therefore they have the same chemical properties, hardness, chemical stability, and so on. They are at the same time polymers because they are obtained from a polymerization process called polycondensation. 1 ton of geopolymer produces 0.16 tons of carbon dioxide, while a ton of Portland cement produces almost 1 ton of carbon dioxide. Means that geopolymer is an environmental friendly material. About the formulation, the reagents to produce geopolymers are aluminosilicate and alkaline solution of potassium, sodium often, and aluminosilicate used can be should be clays like metakaolin or wastes like slag that come from iron production process, or fly ashes that come from other waste that come from production plants of power production plant and other such porcelain and so on. The inerts are added so to the reagents. In our case, the inerts are construction and demolition waste. Geopolymers do not require the presence of Portland cement and show the best properties of ceramics. I mean, good mechanical performance, excellent adherence, they are fire resistance, good resistance to acid chemicals, and low temperature hardening. Using the geopolymer binder composed of metakaolin, slag, fly ash, and silicate, we obtain 2 kinds of products inserting the inorganic CDU or wood waste. The first product called high density geopolymer contains 50% of inorganic waste. The second contains 40–50% of wood from construction waste. The research carried out to optimize these binders was very important and also very difficult because you had to take into account several aspects. The first aspect is the creation of the panels, and therefore the possibility of creating large panels with good mechanical properties and with no defects. The second aspect is the production process of a panel that requires certain characteristics of a mixture, such as fluidity, workability, long setting time, and so on. Another important aspect was the cost and the life cycle assessment of the process. The innovative and efficient building panels coming from this geopolymer mixture therefore had to have important technical characteristics. They had to comply with, for example, energy efficiency, and therefore have comparable performance with the products on the market. They also had to comply with national and European construction standards and regulation. They had to comply with industrial processes, and therefore, as I said before, low viscosity, reduced working time, reduce the number of steps for production. The compliance also has to be for design on the design of this panel, because this panel has to be compatible with known installation techniques and with materials used by workers in the sector. Then we have to comply with safety requirements, and therefore the panels were designed to withstand wind loads and seismic activities, and this has required accurate simulation and effective anchoring system. These are the panel produced. There are of three types. First, a radiant panel for ceiling and wall, side 60 centimeter. The main product produced is the radiant ceiling panel, contain an hydronic circuit. The external surface is made by high-density geopolymer, internal of EPS, and should be mounted on a suspended ceiling rails and has a back side pipe connection. The other products are ventilated facade panel, dimension 60 by 60, is built completely with high-density geopolymer reinforced with metal fibers, and the back with panels of wood geopolymer. Can be mounted in a special structure with special anchor system, and has a low weight. Finally, we have the third panel producer as our ETICS panel. ETICS means external thermal insulation composite system, measure 40 for 19 centimeter, compose always an external layer of geopolymer and internal EPS. Is mounted with special anchors for ETICS, has good mechanical properties, and the design allows the overlapping of panels to reduce the thermal bridges. The surface of high-density geopolymer can have different textures and different colors. The panels can be sized also with to the building application, according to the building application. The first prototype was made at the beginning of 2018, demonstrated the feasibility of the project by producing the first ETICS ventilated facade, and they were installed in Padua near the CNR facilities. After the production of the prototype panels in Padua, the next step was the production in a small pilot plant of much larger number of panels. This upscaling was done in Greece by the partner AMS. There a plant called TUPP, Technology Upscaling Pilot Plant, was designed, capable to upscale a wide range of technologies. In this case, was modified to produce the project panels. The production line was foreseen for the first step for the preparation and pre-mixing of the raw materials, then the mixing of geopolymer mixture, then the panel casting, followed by the curing step, two steps of different temperature, and then finishing with painting storage in a storage room. The design and the construction of a pilot plant adapted for the production of a panel was not the only innovation of this phase. In fact, the upscaling strategy, an upscaling strategy called Six Sigma, well known in the industrial environment, was used to optimize processes and to improve products. This method allows to obtain a final product with 0 defects. And the method foresees a continuous control and analysis of the product and a continuous improvement of the production technique. For example, it can be seen how the evaluation of water absorption parameter of a product has been monitored and has undergone a continuous improvement during the different batches of production. Just a small video to see what's how the production plant works. Sorry. This is the pilot plant, and the first step is the preparation of the raw materials, the solid raw materials and the liquid raw materials. They are weighted and then transferred to the mixer, where the reaction, geopolymer reaction, occur. And after the preparation of the mixture, this was transferred in the casting box. You can see the fluidity of the mixture that thanks to the thixotropic properties can be expanded in the casting box. The mixture was checked in every moment, just to increase the quality of the process. Here, the EPS is glued to the geopolymer mixture, and then there is the step of the post-curing, where the panel is put in a sealed bag and then in an oven, where stay for 12 hours. This is the final panel produced that need more time for post-curing. This is the finishing step with the painting, and the panel is ready for the storage room. Okay, now these are the three products, Ethics ventilated facade and Radiant, produced in the pilot plant, and you can see the installation of this panel. The installation was made in 4 demonstration buildings where that were chosen in different geographical areas to be tested in different climates. In Padua, near Padua, we have installed all the types of panels, then in Athens in Greece, in Belgium in a residential house, and then in Romania other panels. In Padua, you can see that we have installed all the 3 kinds of panels, choosing the right wall for to increase to have the greatest energy efficiency. The Ethics in the north wall, ventilated in the south, and obviously the radiant panel in internal room. At this point, after the installation, I started an activity to monitor the energy performance of a various building. The slide show the various measurements in the pilot demo site in Padua, where the parameters that were measured and monitored before and after the panel installation were, for example, temperature, humidity, thermal transmittance, temperature and water flow of walls, and some data about the comfort of the rooms. Another very important activity was to evaluate the durability of materials of the panels installed. It was necessary to do this work both in the laboratory and in the field. The non-destructive tests were made in the field and tested the behavior of material following over time the stresses suffered by the material. I mean installation stress, degradation of the material, variation of temperature, weather, and so on. These are the list of different type of non-destructive tests performed by a Slovenian partner, s.o.o, and the graphs show the behavior of over time of ultrasonic speed parameter to check for any cracks of the panel. Okay, this is all we're done in this project, and this is short conclusion. The consortium has been designed with very valid partners and with experience in the activities foreseen in the project. We went in 4 years through a path intentionally similar to that a company willing to develop a product from the concept to the potential market introduction. The two selected mixture, inorganic and organic, from CDV, were very effective for the project. The prototypes produced for different uses were considered adequate for a subsequent scale-up on a pilot plant. The various products have been successfully produced and then installed on the demo sites, and the energy and durability assessment of the materials has been done. Thank you very much for your attention, and prepare your question. Please, Emil.
Hello again. I would like to announce the next presentation, which will be given by Mrs. Beatrice Fraga from Technalia about his activities in INOVI project. Beatrice, floor is yours, please.
Hello, everybody. I'm Beatriz. Thanks for the introduction, Emil. Nice to meet you all, even if it's online. Now that Sergio already explained the products of IZNAB project and the manufacturing of those products, I will go through Tecnalia involvement in IZNAB, which was mainly the assessment of the energy performance of these products. So what I'll go through the presentation, I will talk firstly what it is building energy modeling, what's the methodology, and which are the achievements in IZNAB. So building energy modeling through many years, the common practice to design HVAC systems has been to design the building first and then adjust the cooling and the heating loads according to that. However, nowadays there is a common practice to use energy modeling to avoid oversizing systems or undersizing systems. This is a global call. There is a global call for these models to be used towards a more sustainable buildings. There are many advantages for building energy modeling. The advantages are for all the stakeholders involved in the construction sector, like from building owners to manufacturers, like because you can predict your investment return, you can improve your thermal comfort, you can check the characteristics like you have forecast beforehand, before the installation, but you also have a lot of challenges. The main one is what is called performance gap. This gap relies on the difference between the operating building and your software model. So it's really important to have very precise inputs in your model to avoid having these differences between both. The methodology. I will explain a little to have a better understanding of how it works, although it's a very tedious process that I'm going to summarize in a couple of slides. Firstly, you need to collect all the data for the building. With all data, I mean weather files, surrounding buildings, HVAC systems, internal games, building fabric, everything as precise as possible. So then your output will be as precise as possible too. Once you have your 3D model developed, which, as I said, I summarized it in one slide, but it is a tedious process and quite long, then you need to calibrate your model. The calibration needs energy meter data. So you can adjust the results of your model to the real building, and then you can start calculating energy savings and creating your scenarios. This is a very important step to avoid the performance gap I mentioned in previous slides. Once you have your model calibrated, you can develop your scenarios to calculate the energy savings. So you can have your baseline period represented in a model, and you have your reporting period, which is like after retrofitting, which is what we did in IZNAB. Basically, we model the first existing condition of the building, and we compare it with the IZNAB products, with the building after the IZNAB products are installed. So when you have your scenarios, there is a very specific process, which is the hydrothermal evaluation. That is in the case of using passive solutions. That could take another standalone presentation, because it's a very specific, and there is a complex process behind. But this is mainly focused on the condensation. So this is to avoid the risk of condensation when you add passive solutions on the envelope. When you have all this ready, your model is calibrated, you have done the assessment, then you need to validate your model. In order to do so, we use an internal protocol for measurement and verification. this is getting more and more common among experts, because it established a common framework on how to validate your building. So you have the specific steps for everybody to validate how you're building, how to validate your building based on the data is being provided. It's quite flexible, depends on if you have the meter data of the whole facility or maybe only one room, depending on where the solution was installed. The sensitivity analysis allows you to change, because you have this building energy model, you can change one parameter and see how that parameter affects when you change it, which is the energy consumption when you change the thickness of the insulation, for instance, which is what is done in IZNAB, and I'll explain further in the next slides. As a conclusion, overall, I would say energy building modeling is a very powerful support tool, but depends on many factors, and it needs to be very precise to avoid performance gaps. Okay, now transferring all this building energy modeling process to IZNAB project. In IZNAB, as Sergio explained previously, we have these 4 real demo sites where the solutions were installed, and we assess the energy performance of these products in each building. For the Italian pilot demo site in Padova, the 3 solutions, ETICS panels, ventilated facade, and radiant ceiling walls were installed. There's a popping up, okay. Were installed. The panels lead to a reduction in heating demand of 8%, not 80, 8%. Ventilated facade was lower, was 1%. And in the case of the radiant ceiling, we obtained 34% comparing with the fan coils. We compare both systems, although they were very different, because before the radiant ceilings, fan coils were installed. So to see the after and before. In the case of Greece, the ventilated facade was installed in one room, and the ETICS was applied in another room. The ETICS show a much better performance, showing 10.41% kilowatt hours year savings. The ventilated facade was 2.5 approximately, which is also a very good result, but ETICS performed better. Here you can see the sensitivity analysis I mentioned previously, where we change the thickness of the insulation to optimize the solution, which will be the optimum thickness of the solution of the ETICS panels insulated materials. So you can see that for 8 centimeters beyond, it's not worth it to keep insulating. Your cooling demand, your energy demand could actually increase, and your payback period will increase also. So there is it is enough with the thickness we've done in IZNAB. For building demo site, it's a net zero energy building. We model the radiant ceiling of IZNAB, and we compare it with a commercial one. This is the similar case of the last one, because that was the case in the building. So there was a constant weekly monitoring in the building, and there's an obvious resemblance between the commercial panel and the IZNAB panel. Both systems meet the operational condition and thermal comfort, and they behave very similar in terms of pattern. For the case of the Romanian demo site, the ETICS panels were installed in one room, and after comparing the scenario 0, the baseline, how the building was before the installation, we're comparing it with the scenario 2, which is the same as the rest of the buildings. We compare it with the second, we could observe a 22.7 reduction of the heating energy demand along the year. The sensitivity analysis in this case is slightly different, but quite similar. The reduction goes, the energy savings reduction can be from 7.6% till 22%, like depending on the insulation. For 2 centimeters, 7%, for 9 centimeters, 22%. However, the payback period, there is no payback period above 7 centimeters because the reduction in demand is not as large, right? Well, in IZNAB, there were 8 models in total. We have the 4 real models that we explain, we have monitor data, we install on site. But apart from that, we develop on software virtual models. So in total, we have 8 models. Those virtual models were developed aiming to have a broader picture of Europe. So we will have at the end, now this whole picture is in progress. We have all solutions in different climates. So with that, we can actually conclude how every solution impacts and behaves in different climates. This is only the pictures. I won't show results because, as I said, we are building the whole European picture now. So in conclusion, we could say that the climates that we assess had been humid subtropical, oceanic, and Mediterranean. The energy savings for passive solutions have been higher in Spain and Greece. The ethics panels got a better performance in terms of energy savings for all locations. Doesn't mean, this is only mean like getting higher energy savings. Ethics and ventilated facades work more efficient throughout the winter. In a way, radiant ceilings are more suitable for heating than for cooling. The radiant panels have lower distribution temperatures, most of the emitters of this type. And finally, they show a competitive product in all climates, but particularly in oceanic climate in Belgium, where we compare it. I'm putting the example because we compare it with a Belgian site. So thank you very much. This is a quick overview of the energy performance assessment of IZNAB projects.
Hello, good morning again. I have the pleasure to announce the next speaker, Mrs. Rajeshwari Ramashwamy from Oulu University, which present Wall to Loop project. Rajeshi, the floor is yours, please.
Thanks, Emil. Virtual greetings, everyone. As Emil said, I'm Rajeshwari, a doctoral student from University of Oulu, Finland, and I'm here to give an overview of the Wall to Loop project and introduce you all to the consortium members. So, as we all know, every project is based upon having a solution for a particular problem. The problem that is addressed in this project is mineral walls, construction and demolition waste. Mineral wool is an insulation material that is installed in the buildings all over Europe, and it has been observed that after demolition of a building, there is approximately 2.5 million ton per year in Europe alone. Mineral wool waste is obtained, and majority of them is landfill because of the difficulty in sorting and then having recycling difficulty. Even though they weigh it accounts like 0.2% to the total CDW waste. Because of its low density, it occupies more space, like 100-fold space more than other concrete CW waste. So there needs to be some solution for this problem. And also these mineral wools are coated with organic resin. So when they are in contact with soil and with different climate, they can be toxic leachates released into the soil. So the solution that has been found that fortunately mineral wool can be alkali activated when they are in powder form and added with a suitable alkaline solution. It can form geopolymer. As Sergio said, and also I will give a short talk about that. Geopolymers are materials that are like mostly amorphous and aluminosilicates with alkaline and alkaline earth metals. They react with the alkaline solution to form phases that that is similar to concrete like materials. So, and these geopolymers can be tuned accordingly with playing with the mixed designs. So, so the mineral wools also contains these elements, and they can be alkali activated to mineral wool geopolymers. So, the main objective of the project is to use the like divert this mineral wool from landfilling and involve like novel technologies like for sorting, pre-treatment, and creating different products and introducing them to in the market and commercialize them. And these are done in a sustainable way, so which is very important for the current situation in our economy. So I'm very glad to introduce you all to the Ultuluk Consortium members. It is a well-balanced consisting of six small, medium-sized enterprises and 3 large companies and 1 non-governmental organization. As we can see from the figure on the left, the 3 companies, Tree, Termite, and Ries, will carry out and develop smart demolition of mineral wool together with TimeGate from Finland, who will demonstrate innovative solution to waste quality control. And the 3 large companies, Saint Cobain Ecophone, Saint Cobain Finland, and CRH from Netherlands will develop the products as they have a strong experience in developing and bringing new material to the market. And ZAV from Slovenia and X3 from France will develop 3D technologies that will enable development of high value products with complex material structures. And research partners like Oulu University, TU Delft, and ZAC from Slovenia will support with developing the mixed designs for the product requirements and demonstrate activities and market uptake of developed products, as well as they bring knowledge about ZAG will bring knowledge more about LCA and standardization. So for safety and health, human health issues that is involved in the product development, Clover will take care of that health assessment. To ensure effective commercialization of the Ultuluk products, the consortium as a business development partner, Institute of Applied Economics, APS from Denmark. The product that are meant to be used, I mean, formed is dry mix concrete, floor skid, hollow core slabs, and fiber reinforced panels, 3D printing equipment for mineral wool geopolymers, pavement slabs, facade elements, acoustic panels. So from this slide on, I will give you what are some activities that are going on, some product demonstrations that's happening. So for sourcing and sorting of the mineral wool, since mineral wool is like there are different varieties of mineral wool like stone wool, glass wool, we need to have some proper technology and analysis tool for that. So there is a development of VR controlled demolition robot technology that is ongoing to improve the efficiency of mineral wool waste collection. And while every like sourcing time, demolition audit has been like done to get some useful information like how much years that building has been constructed and demonstrated, demolished, so that it will give some understanding about the material state. And for this project, we were aimed to source 20 tons of waste mineral wool, and this has been successfully done. And for the analysis of the mineral wool type, there is time-gated Raman. In this time-gated Raman, we can separate the fluorescence spectra from the Raman. So we can, with the help of that spectra, we can match the mineral wool type. On some testing, we have found that 81.25% is correct to predict the mineral wool type, and 97.2% correct to predict whether there is presence of mineral wool binder. And there is also still ongoing test on it. One of the milling equipment that has been ongoing is screw type mill instrument, which is Milltech IC60, which is installed in Saint-Gobain isobar plant in Forsa, Finland, and it produces 500 kg per hour, and the particle size is less than 100 micrometer. You can see that in the picture, the acoustic panels can be even milled to a powder. So this is very effective. I would like to show you a short video on how this works. You can see that the screw is like grinding the material, and there is a sensor to check whether the materials are going inside or not. And there is also metallic parts installed to push the material inside. Some of the products that are being developed and in good stages are one is acoustic panel, which is developed in University of Oulu. Acoustic panels are the ones that are installed in ceilings to reduce noise. These are lightweight porous geopolymer. You can see from the picture, it is made up of glass wool and stone wool. These are without binder, and their density are less than 400 kilogram per meter cube, and they fit with the product description given by the partners. And mineral wool with binder is still under investigation at University of Oulu. And this is one of the product facade panels, which has been developed by ZAC Slovenia, and they have successfully prepared two good mix designs that is suitable for the pilot production. So it is ready for the pilot production at Termit. And then 3D. So in 3D, we are like constructing the 3D printer that is capable of producing this type of alkali activated material. So there has been like going on different modifications with the instrument, and there are some good results from SAV Slovenia. And then I can show you how it. So this is one of the mix that contains stone wool and glass wool, and it has been successfully done in the lab scale, and industrial scale is also modifying their instrument for the real construction purposes. So conclusions, by careful mixed design of mineral geopolymers, so it is possible to produce a wide range of value-add products with different properties. And as Sergio said, mineral wool geopolymers can enhance the sustainability profile, as it produces less carbon footprint than the original concrete, and then the performances like durability or strength, or these can be enhanced than the traditional concrete. And through this project, we'll be contributing to the standardization of geopolymers, which will be more explained by Wilma. And through this project, we can create a new market for this waste material that is a necessary step for the transition to circular economy. Thanks everyone for your attention. For more information, you can visit the website and you can see how it is going. Thanks.
Thank you, Rajeshi, for your presentation. So now I have the pleasure to announce Mrs. Wilma Dukman from ZAC, which is going to give the presentation on activities in two projects, in Inouye and Wurtuluk. Wilma, floor is yours, please.
Hello, good morning. My name is Wilma Ducman, and I'm from Slovenian National Building and Civil Engineering Institute, called ZAC in short. So ZAC is a partner in both consortia, so like Inouye and Wurtuluk. And in both, today I will present the activities which are common in both projects. So as you have seen, both projects aim to develop building products, and for the building products legislation, it's quite strict. And since Slovenian National Building Institute is notified body for building products, and we also perform life cycle assessment, our part in this both two projects cover legislation background for building sector, technical evaluation, life cycle assessment, which will be also part of today's presentation. So if I give few words about motivation, in all these projects, which are demo projects with high TRL stage, technology readiness stage, approximately 6 or even 7, it's important that we put products on the market. So, but in the building sector, this is important to strictly follow legislation. So it's additionally more complicated. And if we want to get advantage on the market, LCA should be also performed, because this LCA can emphasize the benefits of the new solutions. So if I go to the legislation, as I said, building sector is strictly followed by construction and regulation harmonization regulation. So it requires this regulation CPR, it requires from manufacturers to test products according to specific harmonized standards, if they exist. But these harmonized standards are very well established for the most of the traditional products like concrete, cement, aggregates, bricks, and so on. But in the case when we develop new products, might be a problem because there is no standard. For some specific products, we can also use European technical assessment on, or in fact, we can base our assessment on European assessment document. And after that, we can issue European technical assessment. But also, not all of the new innovative products are covered with European technical assessment. But when we develop the products up to a certain phase, the producer, if he assesses that the product has some market prospect, can apply and ask for the European technical assessment. So, and there is also third possibility. This is national possibility in national that we follow national legislation, but in that case we can now use CE marking. So CE marking is not allowed. So if I schematically is presented here, what you can use to put products on the market. So first case is harmonized standards, like I said, for concrete, cement, aggregates, and so on. Second option is European technical assessment. In both these cases, you're obliged to use CE marking. Then if you do not want to follow this procedure, or you're not able to follow it, you can try in some countries, not in all, you can try through national standards. For example, in United Kingdom, there is publicly available specification for the alkali activated materials, which is in both of our projects. Or you can apply for national technical assessment, but it's also not possible in every country. So now how to start in our project. I will start with IZNAB because IZNAB project is practically at the end, and then I will continue with Multiloop, which has just started. So in IZNAB project, like Sergio explained, 3 types of panels were developed: ATIX-like panels, ventilated facade panels, and radiating panels. All 3 types of panels were also put on demo sites to follow how they behave in real situation. So, but if they want to enter to the market, and because this is building sector, they need to be tested and they need to get kind of a certification. So how to test then these products? First, we need to define precisely the intended use. We can say that it's facade panels, but we need to know whether we'll be in the zone of freezing. So we need to know conditions of the exposure, whether there will be salt present or so on. So we need to define which parameters are then important to be tested. And because there is no standards for geopolymer-based products, we explore cement-based or clay-based specification, but for the same intended use. But because the geopolymers is chemically not the same as cement-based or clay-based material, we need to define if there is any potential problem which is related to the composition or to the chemistry of these new developed materials. So in the case of ATIX-like panels, we have decided to select ATAC 004. This is external thermal insulation composite system with rendering. Rendering here in this case is cement-based material, but in our case, in IZNAB case, this is geopolymer materials. But ATIX is used for the contact facade, the same intention as ATIX-like panels from IZNAB. So we have the same intended use and small differences in final layer. So we decided that we will use ATIX as a background for testing. ATIX is produced by EOTA, what I explained before, so like EAD, European Assessment Document, and it prescribes all the basic requirements tests which needs to be performed before we put ATIX-like system into use. So based on this ATAC 004, we have selected which test needs to be done. So porosity, capillary water uptake, water vapor permeability, resistance to freezing thawing, also the resistance of freezing thawing in the presence of salt if they're used somewhere near the roads or in the marine environment, resistance to carbonation, alkali silica reactivity. These are 2 methods which are not prescribed in the ATAC, for the ATIX. But since we are dealing with new type of material, we need to perform wider testing than for the ATACs based on the cements. So we have performed additionally than thermal shock resistance, adhesive strength, and impact resistance. Here are some photos from the laboratory, how we have performed all these tests. And when we have finished this test, what we can see. So we have tested panels from laboratory production and from pilot production. First things which we can see is that the laboratory results for laboratory panels and for the pilot production are pretty well in line. So what we can conclude is that the pilot production was successful because we successfully meet all the parameters from the laboratory to the pilot to the upscaling. The next thing is that when we compare these results for the pilot production and compare them to the requirements for the ethics-like or ethics, we see that all the requirements are fulfilled. So we can say that this product is suitable for the intended use. Also, the durability parameters are suitable because freeze-thaw, there is no problem on laboratory and pilot scale panels. Then impact resistance is also okay. Resistant is to carbonation, no visible changes. Alkali silica reactivity, again resistant. Sulfate resistant, again resistant. There is only one problem: the material was not resistant in the presence of the icing salt. So we need to exclude this use out of the intended use of such kind of product. So we have defined that product is now suitable for the intended use. Panels were installed on demo places where we have now monitoring on site, because maybe not all the parameters are included in this test procedure, and it's always good if you can have material before wide production you have on site, and you can follow 1 year or 2 years before you decide how to continue. And if the producer of these panels then will see that product has market potential, then they will apply for kind of a certification, like I explained before, for EID. So not only legislation part is important, but also LCA part, because LCA, it's important. It's not legally required yet, but it's important because it's additional benefits on the market when we have it. To perform if successfully, we need to define the goal and the scope, what we will assess during this LCA analysis. In this case, you can see it here. You can see ethics-like panels, and then we prepare life cycle inventory, what I will explain later on. We calculate by Gabi database this life cycle impact assessment, and at the end, it's also important how we interpret these results. So if I continue to present into these stages, for the life cycle assessment, there are many stages, and usually we go only product stage, so cradle to gate scenario. But in the case of IZNAB products, we have decided to go into cradle to grave scenario. So we added beside product stage, which is A1 to A3, and this is production of material, transport of materials, and so on, to construction process stage, A4 and A5, transport of the panels to the construction site and installation of panels. We have taken into account also use stage, but there is generally no need for any maintenance, so we associated this stage with practically zero impact, and end of life stage. So it was also already one question from the audience regarding this end of life stage. So we have predicted that part of the geopolymer panels can be recycled into the aggregates. So this will be also included into the calculation of LCA analysis. So and this is also benefits which is beyond the system boundary stage, because this crushed geopolymer can be used in the road base. So when we go to the calculation, what we can see is ethics-like panel, the production stage, the production stage is the most, that contributes to the most to the environmental impact. So this is the blue column in every stage. So if we focus only on the global warming potential, then the most significant impact is from the production phase. And when we have go further in this production phase, we have realized that this hotspot or weak point in this phase is electricity. So life cycle assessment can also help us in improving research or optimizing research in a way that we get better environmental outcomes. So we made an assessment what could be done if we change electric energy with natural gas, with heat pump, or vacuum heat pipe with solar thermal collector or thermal solar collector, and which is powered by photovoltaic cells. So as you can see, the option 4 for every parameter decrease significantly, really, especially global warming potential, decrease significantly impact on the environment if we are able to change the electricity. So this is something that the future producer will need to have in mind if he wants to improve the production process from environmental point of view. So I have now explained briefly what we have done in IZNAB project. So we have assessed the products. We suggested potential producer how they need to continue in order to get papers for the market, and what LCA analysis can contribute to the research part. In the wool-to-loop project, our involvement will be very similar, but there are different products, not exactly the same. Some of them are similar, some not. So the products which will be developed in the wool-to-loop are dry mix concrete, hollow core slabs, acoustic panels, facade elements, and pavement slabs. So, and again, as it was explained before, for all these products, there is no European standard, there is no national standards. So we need to define intended use of products and especially condition of exposure, whether there will be freezing or salt or water and so on. When we need to define which parameters are important to be tested, then we need to find proper standards, proper basement for tested. We search from cement-based or clay-based or geopolymer national specification for the same intended use. And then we also need to pay attention that geopolymer is not cement, it's not ceramic, and maybe different chemistry can play a role in the final properties. So for the products which will be developed within the wool-to-loop, we have already specified some standards which will be used, like concrete paving blocks. For the acoustic part, we have selected standards. For screed materials, we also selected. Then for facade panels, we have decided to follow European assessment documents, as I have explained before. So kits for external wall cladding, mechanically fixed. We will also use publicly available specification, which is was prepared in the United Kingdom, construction materials, alkali activated cementitious materials. Then some results from RILEM technical committee, which are focused on durability testing of alkali activated materials. And we will also support all this evaluation with life cycle assessment. And if I now focus on one concrete example, so we will develop pavement slabs. For the pavement slabs, we can use either European norm for the concrete paving blocks or European norm for clay paver units. But from both these standards, we have selected which parameters are important to be tested for the intended use. So dimensions are important. Bending strength is one of the most important characteristics if it's used only inside. Then abrasion resistance, if it's heavily loaded with the equipment or pedestrian, it also needs to be assessed. Skid resistant or slip resistance. Then if it's in the freezing zone, we need to define freeze-thaw resistance and resistance to acid. But additional durability will be performed, like carbonation resistance, alkali silica resistance, and freezing in the presence of de-icing salt. With all these tests, I think we will adequately assess the new products, and we will then be able to advise potential producer in which way to continue. So if I now conclude with this part, I would like to stress that when we work on high technology readiness level, then suitable technical assessment of newly developed products and proper legislation addressing is of vital importance because it enables successful market penetration. Because if you don't get papers for the market, you cannot sell this product. So it also, such kind of technical assessment also provides data for benchmarking, because it's important that our product is at least comparable to the competitive products. It's even better if it's better. So, and also life cycle assessment is a tool for environmental assessment, which also gives information about specific environmental burden, like global warming potential, but it also detects weak points or hotspots in all stages and thus enables improvements in this sense. And it serves as a basis on environmental product declaration, what might become even more important in the future, especially for green coal, where some public entities already requires that the products are that the products obtain also environmental product declaration. So in upscaling demo research project, these activities like technical evaluation and LCA analysis support research toward development of products which fulfill technical and environmental requirements and can be then successfully placed on the market. Thank you.
Okay, thank you, Wilma, for your interesting presentation. And I would like to say that was the last presentation of the workshop. Now we have enough time to address the question which we receive on the chat. We have 2 questions up to now, so I would like to give them loudly. The first question: did you assess the possibility of recycle the materials composing the panels, since there are different materials composing them? And I mean it is easy to separate them to recycle the composing materials at the end of the life. I think Mrs. Wilma Duckman from s.o.o already addressed this question, but Wilma, please could you repeat again?
Yes, we have taken into account also this scenario that part of the geopolymer panels are recycled. So in the LCA analysis, we have foreseen that approximately 70% of recycled part can be used for further purposes and 30% is not usable and should go on the landfilling. So this is something we have in mind and something where we work on, because besides being only simply used in road basement, this material shall be characterized also on leaching parameters if it's everything okay also from this point of view. So this is part where we are still active and work on it.
Okay, thank you, Wilma. The second question: are there some standards to be met in order to reuse CDV? If I'm not wrong, there are still no regulation at the end of the waste of CDV. I think, Wilma, it is again a question to you as you are dealing with standardization and you have checked this part. Please.
Yeah.
Please,
I can start, but then I will ask Sergio to complement me, because it's true that there is no European end-of-waste scenario. This is called end-of-waste scenario, where it's prescribed how to deal with different waste stream, in this case in construction and demolition waste. There is no unified procedure, but it's in the every country can decide how we will continue with this, what will be prescribed for such recycling. And since construction and demolition waste was recycled into a fine fraction of aggregates in Italy, I know that Italian partners need to get some permission from local authority. Maybe Sergio, you can add something.
No, it's correct. It was a long travel to have the certification to use this material as and change the name of waste from waste to secondary raw material. But at the end, the Italian legislation has the rules to transform this waste in an SRM. Anyway, is not so easy, but is a common work that people that work in the area of transformation waste to secondary raw material do. The problem was for us to transform, because we had transformed the CDV in a new material that was not preview from the legislation.
Yeah, if I may add, we tackled two major problems, two major issues in this project, because one is how to transfer waste into secondary raw materials. This is the procedure. And second one, when we are developing new products, which is not covered by harmonized standard or European assessment documents by EOTA, then again, we have a problem how to continue, how to adequately assess the products before put it on the market.
Yeah, correct.
Okay. Thank you, Wilma and Sergio. We have the other question. I will give it to you. As far as regulations are concerned, are we talking about no bearing building elements? And the following, are there no Euro codes on such innovative materials, isn't it? So I think it's again question to both of you.
Yeah, in INNOV project, these are non-bearing building elements, so it's not such a problem. In the wool-to-loop project, we will deal also with load-bearing elements, and it's correct that there are Euro codes which can be used for the construction purposes, but mostly for the design, not for materials characteristics. So Euro codes refer to the standards. For example, when we build for clay bricks, Euro codes would define which type of clay bricks, what is the porosity, what is the share of voids, what should be compressive strength. But for the geopolymers, we don't have such standards. So Euro codes can prescribe requirements regarding structural aspects, but they cannot refer to standards regarding material properties. So our intention is to go into direction to apply for European assessment document. This is not such a problem. It takes some time, but usually this can be done when the producer is sure that he or she, that company will go on the market, and then they can apply at the EOTA. EOTA will notify one of the technical assessment body like our institution, or there are many more in European community, and then this institution will prepare tailor-made standards like EID, European assessment documents, and then products will be tested according to this document, and if everything is okay, then European technical assessment will be issued, and based on this assessment, producer will be enabled to put CE marking on the product.
Okay, thank you, Wilma. Sergio, would you like to add something?
No, Wilma is the best, has the best knowledge about it.
Okay, thank you. We are already announced that we have 10 minutes left, so it is enough to finish. As I see, we don't have any questions more. So from my side, I would like to add that INOE project is almost completing project. By this, I mean that we just need to finish some kind of the assessments related with exploitation strategies for European markets and beyond, of course, and business plan, business models for all of key exploitation results which we define, we describe, and this and all other activities which will be present on final conference of INOE project on 23rd of September between 9 and 9 o'clock and 1 p.m. If you are interested on that, visit website of INOE, find the final conference tab and register. Conference is free of charge, but registration is compulsory to send you invitation for online event. So this is more and less all from my side and all from workshop. If some speaker would like to add something to clarify some issues, so please, floors will be yours. So thank you for your attention, and again, please visit the websites of our projects, INOE and World to Look. Thank you.
Thank you to everybody.
Thank you. Bye.
Oh,
Okay.
okay,
Thanks,
thank you.
Bye.
See you. Bye. 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 So nice to meet you, all of you.